6, 5, 4, 3, 2, 1. And booster ignition and liftoff of Space Shuttle Discovery, taking the space station to full power for full science.
Every civilization looks up at the night sky and imagines the same thing. That one day we'll go there. That the stars are destinations, not decorations. But reality has a crueler sense of humor. Because the truth is, after 60 years of spaceflight, humanity hasn't gone as far as our imagination pretends. We are still, in every sense, standing at the edge of the shore, staring out into an infinite ocean we barely understand. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here, and tell me in the comments where you are and what time it is right now. I always find it fascinating to see our little community scattered across the globe. Now, dim the lights, maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. When people think of space travel, they imagine the vastness of the cosmos, galaxies, wormholes, star systems waiting to be explored. But the truth? Everything we've ever physically touched, every world we've ever walked upon, exists within a cosmic distance so small it barely registers on a universal scale. Our farthest travelers, the Voyager probes, are the best symbols of our reach. Launched in 1977, these twin spacecraft were built with the technology of rotary phones and cassette tapes. Yet somehow, they became our most successful ambassadors to the universe. Voyager 1 has now traveled more than 15 billion miles from Earth. It left the solar system's bubble, the heliosphere, and entered interstellar space, the first human-made object to ever do so. But even that incredible achievement is a whisper in cosmic distance. At its current speed, about 38,000 miles per hour, Voyager 1 would take over 70,000 years to reach the nearest star, Proxima Centauri. 70,000 years. That's longer than all of recorded human civilization. It's humbling, almost cruel, that the furthest we've gone is still just a few light hours from home. The galaxy measures in light years, but our technology crawls in miles per second. And yet, what we have achieved is nothing short of miraculous. In the 1960s, when rockets were still experimental and space was a graveyard for early ideas, humanity took its first true leap. The Apollo missions carried 12 men across the void to the moon, 250,000 miles away. It's the farthest any human has ever traveled from Earth. And since December 1972, not a single human being has gone that far again. That fact alone tells a story, not of failure, but of perspective. We reached the moon at the height of political will, when Cold War rivalry made space the new battlefield. But when the flags were planted and the headlines faded, we discovered the harder truth. Space isn't conquered by ambition alone. It demands resources, patience, and risk, all in staggering amounts. After Apollo, our dreams shrank into orbit. We built space stations, Skylab, Mir, and now the International Space Station, a laboratory endlessly circling the Earth. For over 2 decades, astronauts have lived there continuously, floating 250 miles above the surface. It's a breathtaking human accomplishment, but it's also a cage. They're still trapped in Earth's gravity well, still within reach of home in a matter of hours. Beyond low Earth orbit, our exploration has been robotic. Rovers like Curiosity and Perseverance crawl across Mars, analyzing the dust of a dead world. The New Horizons probe gave us our first close look at Pluto. The James Webb Space Telescope peers across time itself, showing galaxies as they were billions of years ago. But even the most advanced machine we've ever built is not traveling to those galaxies. It's simply looking at ancient light that has already made the journey for us. The gap between where we can look and where we can go is the real frontier. To understand how far we can travel right now, you have to understand one brutal fact. Speed kills in space. The faster you go, the more energy it takes. The more energy you use, the more fuel you need. And every pound of fuel makes you heavier, which means you need even more fuel just to move that fuel. It's a vicious cycle that limits nearly everything we can build. Chemical rockets, the kind that powered Apollo or SpaceX's Falcon 9, are miracles of engineering but slaves to physics. They can only convert a tiny fraction of their fuel's mass into thrust. Even our fastest rockets, if aimed toward another star, would take tens of thousands of years to arrive. That's why, for now, our practical universe is measured not in light years, but in light minutes. Radio signals from Mars take up to 20 minutes to reach Earth. That means every robotic command is delayed, a reminder that even our closest neighbor is already distant enough to feel alien. Still, we push forward. SpaceX's Starship aims to change the game, a fully reusable spacecraft capable of carrying 100 people to Mars. If it works, it could make interplanetary travel routine, even if not yet interstellar. NASA's Artemis program plans to return humans to the Moon by the mid-2020s, this time to stay. The Moon would become not just a symbol, but a gateway, a stepping stone to Mars and beyond. The logic is simple. Before you cross the ocean, you build harbors along the coast. The Moon offers exactly that, a place close enough for rescue, but far enough to teach us how to survive off Earth. Its low gravity makes it a perfect launch pad for deeper missions. From there, we could mine water ice for fuel, build habitats shielded from radiation, and test life support systems that might one day take us to Mars. Mars, the red world we've worshipped, studied, and dreamed of, sits roughly 140 million miles away at its closest. A journey there with current propulsion would take 6 to 9 months. A round-trip mission could last years. To live there would mean enduring extreme radiation, dust storms, and isolation that test the human mind as much as the body. But for the first time in history, we have the technology, barely, to make it happen. The Mars dream isn't fantasy anymore. It's a test of willpower. And yet, Mars is not the end. It's barely the beginning. Because even if we mastered Mars, even if we built cities under its crimson sky, the distances beyond it are almost unimaginable. Jupiter is 500 million miles away. Saturn, nearly 1 billion. The outer planets are so far that light itself takes hours to cross the gap. And beyond them lies emptiness, a dark ocean stretching for trillions of miles before the next star. That's where our Voyager probes drift now, carried by inertia, whispering faint signals back to a planet that's slowly forgetting them. They've left the sun's influence, but not our story. Their journey is both a triumph and a reminder. This is how far we can travel. For now. Every meter beyond Earth's orbit has been bought with courage, genius, and sacrifice. But the truth is humbling. Our species is still in its infancy. We have touched the Moon, glimpsed Mars, and sent machines to the edge of the solar system. But compared to the universe itself, we have barely opened the door. And the question that lingers, the one that haunts every scientist, dreamer, and traveler, is this. How do we go further? How do we break free from the slow crawl of rockets, from the prison of time and distance, and step into the true cosmos? Because beyond every boundary we've reached lies another that refuses to yield. Every dream humanity has ever had about space runs into the same invisible wall: distance. The universe is vast beyond comprehension, and every inch of it fights back. It's not just far, it's forbidding. The very physics of existence seem designed to remind us that we are creatures of a single small world, and that escaping it requires more than courage. It requires rewriting the rules of reality. We often talk about space exploration as though it's inevitable, as though progress will naturally carry us to other stars. But if history teaches anything, it's that progress is not a straight line. For every Apollo, there is a Challenger. For every Voyager, a budget cut. The distance between what's possible and what's imagined isn't measured in miles. It's measured in energy, risk, and time. And right now, time is not on our side. Every rocket that's ever flown has one thing in common: fire. From the roaring Saturn V to SpaceX's Starship, we rely on the same principle, Newton's third law. Push exhaust one way, and the spacecraft moves the other. It's elegant, but it's crude. Because chemical propulsion, no matter how advanced, runs on the same ancient law that powered gunpowder. To put it bluntly, we're trying to cross an ocean of stars in a canoe powered by explosions. Even our best rockets, the ones that fling satellites around the solar system, barely scratch the speed needed for interstellar travel. Let's say we wanted to visit Proxima Centauri, our nearest star at just over 4.2 light-years away. Using today's fastest propulsion, it would take over 70,000 years to get there. By the time the ship arrived, every memory of its launch would be dust. To go faster, we'd need a revolution in energy, not an upgrade. Because the faster a ship travels, the more energy it needs to accelerate. And as it approaches the speed of light, that energy demand explodes to infinity. Einstein's equations are merciless. Mass and energy are the same thing. And the faster you move, the heavier you become. At light speed, you'd weigh infinite tons, and no amount of fuel can fight infinity. That's the first wall, the wall of physics. It's not just about technology, it's about nature itself. The speed of light isn't just fast, it's final. And until we find a way to cheat that rule, every dream of star travel remains science fiction. Even if we could move fast enough, the space between stars isn't empty. It's filled with microscopic dust, frozen atoms, and cosmic radiation. Each one harmless at slow speeds, but deadly at high ones. At a tenth, the speed of light, a single grain of dust would hit a spacecraft like a bomb. The impact energy would rival artillery shells, shields would melt, sensors would fry. Space isn't a road, it's a minefield of invisible bullets traveling at unimaginable speeds. Then there's the radiation. Earth's magnetic field protects us from the cosmic rays that constantly bombard the solar system. But leave that shield, and you enter a storm that never ends. The radiation between stars is relentless. It tears through metal, shreds DNA, and mutates everything it touches. For short trips, a week to the moon, a few months to Mars, we can protect astronauts. But for decades-long voyages, no human-made shielding can fully block that radiation without making the ship impossibly heavy. And so, even if we had the speed, the void itself becomes the enemy. It's not just the cold, or the dark, or the emptiness. It's the physics of survival. But the greatest barrier isn't energy or radiation. It's time. Human life is short. Even with perfect health and ideal conditions, a century is rare. To reach another star, even with the most optimistic future engines, fusion drives, antimatter propulsion, we're still talking about centuries, maybe millennia. That means anyone who leaves Earth for such a mission won't live to see the destination. Their children won't either. Generations would be born and die in the dark, their world not a planet, but a machine drifting between suns. Entire civilizations could rise and fall on Earth before the ship ever arrived. That's the brutal truth of space travel. It's not just a physical challenge, but a psychological one. Humanity isn't built for such long loneliness. Our species evolved on a planet with horizons, with seasons, with the smell of rain and the sound of wind. In deep space, there is none of that. Just silence, eternity, and the slow erosion of meaning. A generation ship, a vessel meant to carry life for centuries, would be not just a technical feat, but a social experiment unlike anything in history. It would have to survive not just the journey, but boredom, rebellion, and despair. Because the real enemy in the darkness isn't distance, it's forgetfulness. Still, the story of humanity has never been about surrender. Every wall we've ever faced, we've found a way to climb. Fire gave us warmth, engines gave us flight, electricity gave us civilization. So even though the walls of the cosmos look impassable now, minds around the world are already sketching the blueprints of what comes next. There's ion propulsion, slow but steady, like a cosmic sailboat. Instead of fire, it uses charged particles to push a spacecraft forward continuously for years. It's weak at first, but relentless. A ship powered this way could reach the outer planets far more efficiently than chemical rockets ever could. Then, there's nuclear propulsion. Not bombs, but controlled fusion. The same reaction that powers the stars. Fusion engines could theoretically produce thousands of times more energy than chemical fuel, shrinking travel times across the solar system from years to months. Projects like NASA's NERVA and DARPA's Draco are testing that idea even now. Beyond that lies the boldest idea of all, the light sail. Imagine a spacecraft pushed not by fuel, but by light itself. A giant, ultra-thin mirror that catches photons from lasers or the sun. Each photon adds a tiny push, so small it's almost nothing. But in the vacuum of space, where nothing slows you down, those tiny pushes add up. Over time, you could accelerate to a significant fraction of light speed. That's the dream behind Breakthrough Starshot, a project backed by scientists like Stephen Hawking. They imagine sending fleets of miniature probes, each no bigger than a coin, sailing to the nearest star, accelerated by powerful ground-based lasers. They wouldn't carry people, but they could arrive within decades instead of millennia. If successful, it would be the first step in a new kind of exploration. Not human bodies crossing space, but human eyes. Robotic extensions of our curiosity, flung between the stars. But for all our engines and equations, the hardest part isn't technology, it's trust. Because the truth is, we already can go farther if we accept the cost. We could send people to Mars within a decade. We could build colonies on the moon within 5 years. We could launch fusion-powered ships within a century. The science isn't impossible, it's uncomfortable. The real limitation is us. Every space program competes with politics, economics, and fear. When budgets tighten, space is the first dream to die. When wars begin, rockets become weapons again. When people lose patience, exploration stalls. And yet, the stars are patient. They will wait. Space doesn't care about our politics or our borders. It will still be there when we're ready. The question is, will we survive long enough and stay united long enough to reach it? Because the same technology that could carry us to Mars could also destroy us at home. The same nuclear power that could light our ships could end our civilization. The same intelligence that could build interstellar engines could create machines that replace us before we ever leave Earth. The race to the stars isn't a race against physics, it's a race against ourselves. Someday we will go further, not because it's easy, but because the desire to go is built into us. We are the species that crossed oceans without knowing what waited beyond the horizon.
65 miles per hour.
The same
1.5
instinct that drove
miles
Polynesians
down
into the
altitude, 7
Pacific
miles
and
downrange
Vikings
from the
across the Atlantic will drive someone, someday, into the endless night. Maybe it won't be chemical rockets or metal ships. Maybe it will be something we can't yet imagine. Warp drives bending space-time, quantum propulsion, or digital minds that travel as information instead of flesh. But no matter the method, the meaning will be the same. We looked up and refused to stop. For now, though, our reach ends just beyond the sun's light, where Voyager drifts, silent, ancient, and still carrying our message to the cosmos. A golden record, engraved with the sounds of our world, the laughter of children, the sound of rain, a heartbeat. It's both a greeting and a memorial, a reminder that, even at the edge of our reach, we are still trying to be known. The question then isn't how far we can travel, it's how far we're willing to imagine. Because imagination is the first form of propulsion, and every real journey begins there. When the first humans looked at the stars, they were trapped on a single world. Now, we have touched the moon, reached the edge of the solar system, and built machines that see the birth of galaxies. If that's what infancy looks like, imagine adulthood. We are still at the beginning. The walls around us are not the end. They are simply the next frontier waiting to fall. If this gave you a new perspective, hit subscribe. The stars are calling, and history has shown we always find a way to answer. For as long as humans have looked up at the night sky, the stars have whispered to us. They are distant, cold, and indifferent, yet somehow familiar, like old friends whose presence we can feel but never touch. Every generation has dreamed of reaching them, imagining vessels that could carry our bodies, our hopes, and our stories across the unimaginable darkness. They will inherit the choices that will define whether humanity remains bound to Earth or takes its first steps among the stars. History has shown that we are the species that dares, the species that builds, and the species that endures. The next century will test all three. And if we rise to the challenge, the story of humanity will continue, not just on one fragile world, but across the solar system, and perhaps eventually, among the stars themselves. Humanity has always looked outward. The horizon is not a limit. It is a challenge, a question whispered by the universe. How far will you go? The next frontier is not the Moon, Mars, or even the outer planets of our solar system. It is the stars themselves, countless suns scattered across an infinite void. To colonize these distant worlds, we must confront not only engineering and technology, but the profound ethical and philosophical questions that come with expanding life beyond Earth. Colonization is not merely about survival, it is about choice. It is the conscious act of taking our fragile existence and planting it in places that may never have known life. With each world we settle, we carry both opportunity and responsibility, creating futures that may span centuries or millennia. One of the most profound dilemmas in interstellar colonization is this: what right do we have to alter worlds that may already host life, or that exist in pristine, untouched states? Even a seemingly lifeless planet could contain microbial ecosystems, chemical processes that have persisted for eons, or undiscovered forms of life that challenge our understanding of biology. The principle of non-interference, similar to the Prime Directive popularized in fiction, may one day govern humanity's actions. Do we have the moral authority to terraform a planet, to introduce Earth-based life, or to extract resources from a world untouched by civilization? Every act of colonization carries consequences that we may only understand centuries later. Yet inaction also has consequences. Earth is finite. Our population grows, our resources dwindle, and our environment strains under the weight of civilization. If humanity is to endure, expansion may be necessary, not for conquest, but for survival. The ethical challenge is to balance necessity with responsibility, ambition with stewardship. Colonization forces us to confront what it means to be human. On Earth, we are bound by geography, politics, and biology. In space, these constraints shift. Generations may live and die on worlds far from Earth, developing new languages, cultures, and identities. Humanity will not remain monolithic. It will diversify. This raises profound questions. If humans born on Alpha Centauri never see Earth, are they still the same species? History shows that isolation and new environments shape culture, technology, and governance. Communities on distant planets will need to solve problems in ways Earth-based societies cannot imagine. Laws, ethics, economies, and social structures may diverge radically. In this sense, interstellar colonization is also a philosophical experiment, a test of what it means to survive, adapt, and thrive in the universe. Terraforming, the process of reshaping a world to support life, exemplifies both the promise and peril of human ambition. Mars, Europa, or Titan may one day be altered to sustain ecosystems, yet each act of transformation carries risks. A miscalculation in climate engineering could make a planet uninhabitable. Introducing Earth life could destroy native biochemistry, even if microscopic. Here, ethics and engineering intersect. Colonization will require not only technological mastery, but moral foresight. We are not merely visitors in space. We are architects of futures we may never witness. Every decision echoes across generations, shaping societies, ecosystems, and the legacy of humanity itself. Even if we solve the ethical dilemmas, the physical challenges of interstellar travel are staggering. Distances are measured in light years, travel times in decades or centuries. Radiation, cosmic debris, and the effects of long-term isolation pose threats to every human life beyond Earth. Generations may live and die aboard starships. AI and robotics may handle much of the work, but humans will need to endure psychologically and socially. Communities will require education, governance, and a shared purpose that transcends immediate survival. Interstellar colonization is not just an engineering challenge. It is a test of human resilience, creativity, and cooperation. History offers lessons. Isolated societies on Earth survived in extreme environments, deserts, Arctic tundras, and remote islands, because they adapted, cooperated, and innovated. Space will be far harsher, but the principle remains. Survival is as much social as it is technological. Those who endure will be those who understand both themselves and the environment in which they live. AI will not merely assist in colonization. It may precede humans entirely. Autonomous probes could prepare distant planets, analyze environments, and construct habitats before humans arrive. Machines may carry knowledge, skills, and tools across light years, ensuring that the first human settlers inherit worlds ready for life. This raises philosophical questions. If AI prepares a planet, is humanity truly exploring it, or merely inheriting the work of our creations? Does exploration lose its meaning if we rely on machines to endure the initial challenges? The answer may lie in collaboration. Humanity and AI may be partners, not competitors, extending life, culture, and knowledge into the galaxy. If humanity endures the next centuries, the eventual outcome may be nothing short of astonishing. A civilization spread across stars, with human and post-human communities linked by ideas, trade, and shared culture. Life could thrive in ways Earth alone cannot sustain. Planets, moons, and artificial habitats could host diverse societies, each adapted to its environment, yet connected by a common heritage. But this vision demands foresight, ethics, and resilience. Expansion must balance survival with stewardship, ambition with responsibility. The mistakes of Earth, environmental destruction, resource depletion, and social collapse are lessons we cannot afford to repeat. Interstellar colonization is not merely an opportunity. It is a test of whether humanity can rise above its flaws and reach its full potential. What will humanity leave among the stars? Knowledge, culture, and life itself. Each colony, each habitat, each journey carries the potential to preserve not just our species, but the essence of what it means to be human. Curiosity, courage, and creativity. These are the true payloads we carry into the void. Colonization will be neither easy nor guaranteed. The universe is indifferent, unforgiving, and vast beyond comprehension. Yet history teaches that humanity thrives when it dares, when it prepares, and when it acts with vision and purpose. To expand into the galaxy is not a mere dream. It is the continuation of our story, written in light years and generations, in courage and perseverance, in curiosity and wonder. Those who take the first steps may never see the fruits of their labor. They may plant seeds for civilizations they will never meet. But in doing so, they ensure that life, culture, and knowledge endure. Humanity becomes not just a species, but a legacy. A presence that stretches across space and time, a testament to the power of imagination and the resilience of life itself. The leap from exploring a single planet to inhabiting multiple star systems is not merely a technological challenge. It is a transformation of what it means to be human. History has shown that every time humanity leaves a familiar home, we must invent new ways to survive, organize, and thrive. The first settlements on the Moon or Mars will be tests of engineering. Interstellar colonies will be tests of civilization itself. To understand the next stage of our journey, we must look at three intertwined pillars: technology, society, and identity. Each will define whether humanity becomes a species that endures in the galaxy or a fleeting spark lost in the void. No human settlement can thrive without reliable technology. Life beyond Earth is harsh, unforgiving, and unrelenting. Spaceships must protect us from cosmic radiation, provide oxygen and water, recycle waste, and generate energy for years or decades. Habitats must withstand temperature extremes, micrometeorite impacts, and the slow erosion of resources. AI and robotics will be indispensable. Autonomous systems will manage everything from mining asteroids for resources to maintaining life support systems on distant worlds. Machines will not just assist humans. In some cases, they will precede us, preparing planets for our arrival and building the infrastructure we require. Propulsion technology will define our reach. Fusion engines, antimatter drives, and other advanced propulsion methods may allow interstellar travel within human lifespans. Every advance reduces distance and time, turning the infinite void into a navigable space where colonies can communicate, trade, and support one another. Even with technology, redundancy will be crucial. Every system will need backups, fail-safes, and contingency plans. In space, there is no emergency room, no rescue fleet. Survival depends on foresight, preparation, and the ability to adapt when things go catastrophically wrong. Technology alone is insufficient. Humans are social creatures, and the success of a colony depends as much on culture and governance as on engineering. Interstellar settlements will face isolation, extreme conditions, and the psychological strain of distance from Earth. Communities must be designed to endure both physically and socially. Governance will be a central challenge. Who makes decisions on a planet light years from Earth? How are disputes resolved when communication with Earth takes decades? What rights do individuals have, and how is justice maintained in a society spread across the stars? History shows that isolated communities are prone to conflict and corruption, but it also shows that humans are capable of remarkable cooperation when survival depends on it. Education and culture will be vital. Knowledge must be preserved, adapted, and passed down across generations. Skills that sustain life, engineering, agriculture, medicine, will be as valued as philosophy, art, and ethics. Colonists will need to maintain both the practical and the intellectual pillars of civilization to survive and thrive. Resources in space are finite. A settlement on Mars, a station in orbit, or a colony on an exoplanet cannot import everything from Earth. Every gram of water, oxygen, food, and fuel must be accounted for. Economics in space will be a matter of survival, not just profit. Resource allocation will require careful planning, trade networks between colonies, and perhaps even entirely new systems of value. Asteroid mining will revolutionize access to metals, water, and fuel. Terraforming projects may transform planetary surfaces into sustainable ecosystems over centuries. But each step must be carefully managed. Misallocation or overexploitation could doom a colony before it truly begins. In this sense, economics becomes more than currency and trade. It becomes the art of sustaining life itself, balancing scarcity with innovation, and ensuring that survival does not come at the expense of morality or ethics. Perhaps the most profound challenge of multistellar civilization is the question of identity. What does it mean to be human when our children are born on worlds millions of miles from Earth? When Earth becomes a distant memory, a legend, or even a religious artifact, how will culture, language, and values evolve? Generations born off-world may not identify with Earth-centric traditions. They may develop new social norms, new governance structures, and even new physical adaptations to their environments. Gravity, radiation exposure, and diet could subtly change human physiology over centuries. Humanity in space may diversify in ways unimaginable, a single species branching into multiple variations adapted to the cosmos. This is both a risk and an opportunity. Cultural fragmentation could lead to conflict, but it could also create resilience, diversity, and innovation on a scale Earth alone could never sustain. The key is to preserve the essence of what it means to be human: curiosity, creativity, compassion, while embracing adaptation and change. With great power comes great responsibility. Colonizing other worlds is not just a technical achievement, it is an ethical act. Introducing life to lifeless planets, altering ecosystems, and spreading human influence across the stars carries moral consequences. Mistakes could be irreversible, consequences felt for generations. Humanity must develop principles of interstellar stewardship. We must balance survival with respect for the cosmos. Expansion should not be exploitation, but careful, conscious adaptation, ensuring that life, knowledge, and culture endure without unnecessary destruction. History teaches that empires rise and fall, often because of overreach or mismanagement. Multistellar civilization is not merely a scientific project, it is a philosophical one. It challenges us to reconsider our place in the universe, the meaning of life, and the legacy we wish to leave behind. Every colony, every ship, every settlement is a question posed to the cosmos. Can humanity endure? Can we adapt? Can we rise above our limitations? The answer will not be known for centuries, but the attempt itself defines us. Expansion into the stars is a mirror of human ambition, courage, and resilience. It is proof that we refuse to accept our fragility, that we strive to endure, and that we are willing to carry our knowledge, culture, and values across the abyss of space. By the end of the century, humanity may still be confined to the solar system, but the foundations of a multistellar civilization will be laid. Technology perfected, governance tested, communities resilient, and ethics refined. These are the stepping stones for the next millennia, when humans, or their descendants, may inhabit dozens, hundreds, or thousands of worlds. History is filled with explorers who ventured into the unknown, guided by curiosity and courage. Space is the ultimate unknown. It will test us, challenge us, and if we succeed, elevate us. The legacy of a multistellar civilization is not just survival, it is the enduring presence of life, culture, and consciousness in the vast, indifferent universe. From the first spark of fire to the first human footprint on the moon, humanity has always been defined by one thing: the urge to go further, to see what lies beyond the horizon. That same impulse now drives us to the stars, to worlds we have only glimpsed in telescopes, to planets orbiting suns light years away. Our journey through space is more than a scientific endeavor. It is a test of our courage, ingenuity, and morality. We have learned from history that survival is never guaranteed. Civilizations collapse, economies fail, and dreams are lost when preparation falters or trust is blind. Yet history also shows us that those who plan, adapt, and dare are the ones who endure, who transform crises into opportunity and challenges into legacies. Space is the ultimate test. It is indifferent, vast, and relentless. To survive, we must harness technology, build resilient societies, cultivate skills, and preserve knowledge. We must think ethically, govern wisely, and remain humble before the immensity of the universe. But those who succeed will do more than survive. They will create a new chapter of life itself, extending humanity across planets, stars, and perhaps one day, galaxies. Every colony on Mars, every ship to the outer planets, every probe sent to the nearest star is part of a larger story. It is the story of life refusing to be confined, of intelligence striving to endure, of curiosity and courage shaping destiny. The cosmos will not bend to our will, but humanity, through resilience, preparation, and imagination, can leave a mark that echoes across light years and centuries. The journey will be difficult. Some will fail, some will be lost, and some lessons will be learned too late. But that is the nature of exploration. The risk is inseparable from the reward. And for those who look up at the night sky and see not darkness but possibility, the adventure is already beginning. History has always been a guide. It tells us that collapse and danger are constants, but so are adaptation, ingenuity, and survival. Space is no different. The challenges are immense, but the potential is boundless. Humanity's legacy will not be written only on Earth, but across the stars, carried by those who dared to venture further, think bigger, and act with vision. Because in the end, the universe does not ask whether we are ready. It simply waits. And those who prepare, who dream, and who act will write the next story of life among the stars. If this perspective inspired you, hit subscribe. The universe is vast. Humanity's journey has only just begun.
One, booster ignition and liftoff of Discovery, hoisting harmony to the heavens and opening new gateways for international science. Discovery has cleared the tower.
Houston now controlling.
Roll program. Roger, roll, Discovery.
Discovery's roll maneuver is complete. Is now in a heads down